So 2.4 day 1 notes is using linear models, and our goal is going to be to write linear equations that model real world data. What is slope-intercept form? What does that look like? Y equals mx plus b. Okay. And there's some information that goes along with that. And on a quiz, if I were to ask you for slope-intercept form and state what the variables represent, you'd only get half credit if this is what you wrote. What do the variables represent? What does the m represent? Good. And what's the b represent? The y-intercept. So I need to also write 0, comma b is the y-intercept. Because I wouldn't just say b is the y-intercept. I'd say 0, comma b for my y-intercept. Because if I said the y-intercept is something like 7, I wouldn't earn points for that. I'd have to write 0, 7 for the y-intercept, because the y-intercept is a coordinate point. To write it as a coordinate point, you need the x and the y coordinates. So, this first example says Hunter gets on the highway in Fowlerville traveling 60 miles per hour. The first thing that we have to do is define our variables. We have to define x and we have to define y. Okay? They gave us a rate. Miles per hour is a rate. What could be another example of a rate? What are other examples of rates that you guys have heard of? Kilometers per hour. What else?
FPS. Feet per second.
Feet per second? Is that what you said? Yeah, feet per second. That would work, feet per second. Meters per second. What else? What about RPMs? What's RPMs? You know, in your car, how they have RPMs? What's that stand for?
The speed the motor is rotating at.
Rotating, so it's revolutions per minute is what it is, right? You guys heard of that? That's a rate, revolutions per minute. What do all of them have in common? Some kind of time. Something per something. That per part is the part that makes it a rate. Okay? Miles per hour, revolutions per minute. The per part means that it's division. So the way that you could write miles per hour is miles per hour. You write miles over hours. Per just means to divide. Okay? Now your rate is going to be your slope. Because your slope is also a rate. It's the change in y over the change in x, or y2 minus y1 over x2 minus x1. You have the change in y over the change in x. Do we remember how we use that? That's called delta. It means change. So if you're not sure what that triangle means, maybe above write the triangle equals change. Change in y over change in x. Okay? So that means that miles has to be how y is measured because it's on top. So your y is being measured in miles. We write that in parentheses because that's not what it is we're measuring, but that's the unit that we're measuring it in. Okay, so your rate's going to tell you your units for both the y. How do we measure x? What unit is x going to be in? Hours. Okay, If I'm measuring in hours, what is it that I'm actually measuring? If my unit is hours, what is it that I'm actually measuring? Time? Time is measured in hours, right? What does miles measure? A distance. And you could be more specific here and say your distance from Fowlerville. Because he starts in Fowlerville and he's traveling at 60 miles per hour. So it says, write an equation to model Hunter's distance, y, from Fowlerville after traveling for x hours. So our equation here would be y equals, we're always going to write our equations in slope-intercept form unless it's stated otherwise. Y equals, what's our slope? What was the rate that it gave us? 60. So we have 60 x, y equals 60x plus b is your y-intercept. How far does he start from Fowlerville? When he starts, how far away is he from Fowlerville? He's in Fowlerville. So how far away is Fowlerville from Fowlerville? 0. Do I have to write plus 0? No, you don't have to. So y equals 60x would be our equation here. Okay. To graph our equation, it says to make sure to graph your graph includes at least 5 points. Maybe it will be easiest if we made a table. There would be 5 points, 0, 1, 2, 3, and 4. If I plug in 0 for x, what's 60 times 0? 0. What's 60 times 1? 60. What's 60 times 2? 120. What's 60 times 3? 180. 60 times 4? 240. 240. 4 times 6 is 24, add the 0. Okay. Cool, now that we have those, we're going to actually go and plot them. So 0, 0 point, right 1 up 60. 60 is going to be directly into between 40 and 80. Mrs. Fox was nice and she already put scales on our graphs for us. 2, 120, 3, 180, 4, 240. Now, if there is room, you want to make sure you plot at least 5 points, but if there's room, we will keep going, okay? Now, you can kind of see the pattern. You're going up 1.5 over 1, up 1.5 over 1. So I'm just going to continue this pattern until I run out of graphs. So you will plot more than 5 points sometimes if your graph has room. Does that make sense? Then I would use a straight edge to connect all of those. Because is Hunter going to be driving between the time 0 and time 1 hour? Or does he disappear during that time and just appear after 1 hour somewhere else? No, he is going to continue to drive. So we have to connect these points because it's a continuous line. He's still driving in between 0 hours and 1 hour. That's why there's such thing as 30 minutes or 45 minutes, which is a half hour or 3/4 of an hour. Okay. You with us? Where's your pencil? You got it written down? Okay. All right. So then we also have to label our axes. What axis is this one? Your x-axis or your y-axis? X. So we look up here and how did we define our variable? We defined it time measured in hours. So that's how I'm going to label it. How would I label my y-axis then? Yep, distance measured in miles. Okay. I also need to put a title on my graph. Should have had another box up here, but I forgot. Okay. the title is always going to be y versus x, okay? Have you ever heard of that in your science classes? I see some nods. Yes, cool. Okay, so y is going to be your distance versus the x was your time. So this is a distance versus time graph. All right, so that was part C. Graph your equation. Make sure your graph includes the labels and at least 5 points. We have all 3 labels. We have more than 5 points, so we can keep going. What does the line represent? It does have a positive slope. Yes, it does, because it goes up as you go to the right. But what does that line tell you? At any given time, if I found a point on that line, what would it tell me? Yes, how far Hunter will travel at a given amount of time. So Hunter is traveling at a rate I'm going to take both of those ideas together and we're going to write a sentence. So the fact that it has a positive slope, the slope is telling us how far he's traveling given amount of time, and that rate is 60 miles an hour. So we're going to put all those ideas together. Hunter is traveling at a rate of 60 miles per 1 hour. And that's what that line is representing. For every 60 miles, it will be 1 hour that will pass. How far away from Fowlerville is Hunter after 3.5 hours? Okay, now we know that our equation here is y equals 60x, and I can't always find 3.5 on my graph and figure out exactly where this is because I know it's between 200 and 240, but I can't really see exactly where it would be. So because of that, we're going to have to use the equation that we wrote. Okay? 3.5 hours. Is this going to be an x or a y? Is that a time or a distance? That's a time, so that's going to be your x. You are looking for how far away. That's a y. The y is what we don't know. So we're going to leave y as y because we're going to have to solve for it. Equals 60, x we know is 3.5. And what we're going to do is we're going to solve for the unknown variable. So in your calculator, what is 60 times 3.5? What is it, 210? How far away? Y is 210. How do we measure y? What unit do we give it? Miles. I should always write this as a sentence. Okay, if I'm answering a question like this, if I'm working in a story problem, I should answer it as a sentence. So Hunter will be 210 miles from where? From Fowlerville. After 3.5 hours. How does that look? So far, so good? Okay. So that would be how we'd write that sentence. Always double check that that makes sense, okay? Because when we're dealing with story problems, they are going to be accurate. They're going to make somewhat sense. So let's look. After 3.5, does it look like that's about 210 here? It looks like it. So my graph looks good based on my algebra work that I also did. Both of those match up, so I'm okay with it. And it makes sense that after 3.5 hours, you could travel that far. Okay. All right, if you flip this over, there is another example. Okay? There are two different types of story problems you will deal with. Okay? The first one, we'll write it down here on the bottom. If you're given a rate, you're actually given m, which is your slope, and 1 point. In this situation, we were given the y-intercept because the y-intercept was at 0. Okay, but you're given either the slope and 1 point, or in scenario 2, or the type 2 problem, we're going to be given 2 points. We're not given a rate. So we're going to write that one in next. So when you're looking at a problem on your assignment, you have to ask yourself, am I given the slope? If I am, I'm going to follow type 1 type of example. The example 1 is problem type 1. Okay? Can I go ahead and flip this? You have that down? Okay. So example 2 is going to be problem type 2. Problem type 2 gives 2 points. So that's like this example here on the back. It says, Audrey burns a candle. After 1.5 hours, the candle was 8 inches tall. After 3 hours, the candle is 6 inches tall. So this is actually giving us 2 points. It's giving us 2 x's and it's giving us 2 y's. What should we make the x? Your hours or the inches? Hours. X is always going to be time. So x is measured in hours. Now that's a unit, so we're putting it in parentheses. That's not what we're measuring. Okay? If it's hours, what is it that we're measuring? Time. So you have x is time measured in hours. So in parentheses, you put hours. That's really spaced out. I don't like it. Wait. Okay. Then what is y going to measure? What is 8 inches tall or 6 inches tall?
Height.
The height. So y is going to be the height, and what unit do we measure the height in? Inches. Good. So when we go to write this equation, now writing this equation is going to take a little bit more work. Sometimes it takes a little bit more work to write this equation too because you'll be given slope and a point. What's the easiest way to write an equation if I was given slope and a point? Point slope form. Yeah, point slope form. And then you'd have to convert it to slope intercept form. Okay? What about 2 points? How can you write 2 points as an equation? You're going to have to do a little work here first because you're going to have to find the slope. So the first thing when we go to do this, you're going to have to first identify the 2 points. So there's your 2 points. Then you're going to have to use the 2 points to find the slope. So what's the equation to find slope? y2 minus y1 over x2 minus x1. Right? Okay. Then we'll have 2 points and a slope. We'll write it first in point slope form, which is the y minus y1 equals m times x minus x1. And then we'll convert to slope-intercept form, because that's how we're always going to write our equations here. Okay, so that's going to be our outline here. I'll zoom in so you can get this written down. So we're going to come up with our 2 points. We'll use the 2 points to find the slope. Once we have the slope, we'll have a slope, and we can use either of the 2 points, it doesn't matter, to write it in point-slope form. And once you have it in point-slope form, we're going to convert that to slope-intercept form. Okay, so those are our steps here. So, give me one of the points. What would be one of the points? What would it be? 1.5 and 8. 1.5 is our x because that's going to be time. 8 is our 8 inches tall, so that's your height, so that's going to be your y. So that's 1 point. 1.5 comma 8 is 1 point. What would the other point then be? 3 and 6. Which one goes with x and which one goes with y? X is time, so which one of those is time, the 3 or the 6? The 3. The 3 hours is your time. Y is your height, so 6 inches tall is the height. So here we have 2 points. Okay, now we're going to go, and if you want 1.5, we should probably write this as a improper fraction. So 2 times 1 is 2, plus 1 is 3. So this is actually 3 halves. One and a half is equal to 3 halves. Okay, that's going to be a little bit easier to write out in my slope formula. So I need to assign an 0.1 and a 0.2. y2 is 6 minus y1 is 8 over x2 is 3 minus x1 is 3 halves. 6 minus 8 is negative 2 over 3 minus 3 halves. If you don't know how to do that, your calculator will tell you how to do it. If you've downloaded that Calculate 84 app, it'll be just like using this calculator. 3 minus 3 halves. I'm not going to write it as 1.5 because I'm not going to be allowed to use decimals. So instead, if I hit math and convert it back to a fraction, it's just over 3 halves. Okay. Or you could have written 3 as 6 over 2, because that's 3 over 1, so times the top and the bottom by 2. So you'd have 6 halves minus 3 halves. 6 minus 3 is 3 halves. So you'd have to get a common denominator, or you can use a calculator, doesn't matter. Okay? Now, when you divide by a fraction, this is negative 2 over 1 divided by 3 halves. How do we do a fraction divided by a fraction? Keep, change, flip. So negative 2 over 1, instead of divided by, we're going to multiply by. Instead of 3 over 2, we're going to write it 2 over 3. What do I get when I multiply that? Negative 4 over 3. Okay. Now I would not write this as a decimal, because if I would have put this in my calculator, negative 2 divided by, I'd have to make sure the 3 halves was in there. I cannot write negative 1.3 as my slope because that wouldn't be accurate. That would be rounding. It wouldn't be an exact answer. However, if I did that in a calculator, I could then hit the math button and the fraction button to figure out it's the same thing as negative 4/3. I don't care if you do it by hand here or if you use a calculator and convert it to a fraction. But you have to convert it to a fraction because you cannot leave it as a decimal. Because negative 4/3 is not the same value as negative 1.3. Negative 1.3 is rounded and no longer exact. Okay. All right, so then we write it in point slope form. Which point do you want to use? You want to use the point with the fraction or the 3/6 point? I would recommend the 3/6 point. Okay, so y minus your y1 would be just the y of that point, so 6, equals the m was negative 4/3. X minus, your x of that point was 3. Okay. Remember, for it to be an equation, you need an x still, you need a y still, you need an equal sign still. Okay, and now we have to work at making it look like y equals mx plus b. So we have to get rid of the parentheses. A negative times a negative is turning into addition. 4 times 3 is 12. 12 divided by 3 is 4. And then what do you have to do? Add 6 to both sides. When I add 6 to both sides, I'm going to have y by itself. Negative 4/3 x. I'd have 6 and 4 is 10. So y equals negative 4/3 x plus 10. I can write in that plus 6 too if you want. So we wrote the equation. Now this one takes a little bit more work because you have to find the slope, whereas the last one, it gave us the slope. Okay? If it gave you the slope, then you wouldn't have to find the slope here, but you'd still have to use the point and the slope that it gave you to write it in point slope form and convert it. Okay. The next step says to graph your equation and make sure your graph includes at least 5 points. So, what should I graph first on this graph? What's the first point I should plot? 10's not a point though, so what point would I plot? It uses 10, but what is that point? 0, 10, yes. So I'm not going to move left or right at all. I'm going to go up to 10 on my y-axis. Okay. What's another point I should plot? Yes, 1.5, 8. 1.5 up to 8. Why should I make sure that's on there? It told me that that was a point, so I should make sure that's on there. What else should I plot? 3, 6. Then I should make sure that I'm going down 4, right 3, and plot as many points as I can. Down 4, right 3. Down 4, right 3. Do I have 5 points on there though? Not yet. So let's figure out, this one went down 2, right 1.5. Down 2, right 1.5. Down 2, right 1.5. It continues that pattern. So there's 5 points. I'm going to make sure to connect it. What should I label my x-axis? Time measured how? Time measured in hours. I make sure I have to put the unit in parentheses. How do I measure y? What's y measuring and how do I measure it? Height and inches. And then I also need a title on here. So what's my title going to be? Height versus time. Very good. I think my graph should be complete. I have the x and the y axes labeled. I have a title. I count. I make sure I have at least 5 points. I connected those with a straight edge. Okay. What does this line represent? What does this line represent? Yes, the height of the candle over a specific amount of time. But let's actually put that idea of slope in there. So what is our slope? Our slope is negative 4 over 3. What was the top, our y measured in? What was y measured in? What unit? Height, which was measured in what unit? Inches. So negative 4 inches, what was the 3 measured in? Your x. Your y's over your x's. Hours. So what this line is going to represent is that the candle height is decreasing by, and you could write this 2 different ways. You could write by 4 inches every 3 hours, or you could write by 4/3 of an inch per 1 hour. Yeah. So that would be one option. I'm going to write the other option next to it, so I'm going to zoom out a little bit. That means inch. Are we okay with that? 4/3 of an inch per hour. If there was only 1 there, it would be a foot. 2 is inches. And the last question asks, when will the candle burn out? When will the candle burn out? So if it's asking when, what variable will we be looking for? Are we looking for an x or are we looking for a y? It's asking when. Are we looking for time or are we looking for a height? Time. When is time? So time is what variable? The x. So our x is what's in question here. Our x is the part that we don't know. That means when will the candle burn out? They gave me the height. What would the height then be when the candle burns out? What is the height when the candle burns out? What is it? 0, yeah. When the candle burns out, the height is going to be 0, right? So they're giving you the y, you're looking for the x. So we're going to plug this in. Our equation was y equals negative 4/3 x plus 10. But they gave us the y is 0. So 0 equals negative 4/3 x plus 10. And now what we're going to have to do is solve for x. Do we like dealing with fractions? No. So what should we multiply everything by? 3. So if you go through and multiply all terms by 3, we can get rid of those fractions right away. 3 times 0 is 0. 3 times negative 4 is negative 12. Negative 12 divided by 3 is going to be negative 4x. That fraction goes away. What's 3 times 10? 30. And I don't have to deal with the fractions anymore. How do I get x alone? Before I divide by negative 4. Subtract the 30. Get that x term alone first. The reason why is because a lot of people will divide that by negative 4, but they'll forget to do it to all terms. So it's much easier if you narrow down the terms before you then. Now I will divide by negative 4. Negative 4 over negative 4 turns into 1, so on the right side I have x equals negative 30 over negative 4, turns into a positive, and it's about 7.5. Okay, so x is 7.5. How do we measure x though? What unit? What's the unit for x? Go back up and look where we defined our variables. X was measured how? What unit? Hours. Okay, I'm looking up here where it says define your variables. X was measured in hours. That's my unit I always use for X. Do I write X equals 7.5 for my answer here? No, I'm going to write my answer as a complete sentence. So my answer is the candle will burn out after about 7.5 hours. That word about here is used often, or approximately is used often, because in real life, things are not, there's always room for human error, okay? So because there's room for error, that's why it always says about or approximately. But we're going to use our equations to figure it out exactly as close to possible as we can. Is that okay? So this scenario is giving you 2 points. Now let's look at your first assignment. Okay? If we read about Roman's pools, is it giving you a rate or is it giving you 2 points in this scenario? Where's the rate? Yes, 50 gallons per minute is a rate. Okay, so there's your rate. There's your slope. Now, sometimes you're going to have to look because this says drain. It's draining, so it's decreasing. So what kind of rate are we going to have, a positive or a negative? A negative. So even though they gave you a rate, they're not going to tell you it's a negative 50 gallon per minute rate, but your M is actually going to be negative 50 here. Okay. Let's look at the second example because you only have 2 on this assignment. It says Jenny plants a 5-foot tall tree that goes an average of 8 inches per year. Does this give you a rate or does it give you 2 points?
Rate.
This is also a rate. 8 inches per year is a rate. Okay, so it's giving you the slope on both of these. Okay, so you should have plenty of time to finish these 2 problems today. And then also get a start on assignment 2, which assignment 2 gives you ones that have 2 points, which you can see I set them up for you. It actually shows you the 2 points. So you should finish assignment 1 and we'll get started on assignment 2 today. So make sure you check in assignment 1. You do not have to finish assignment 2 today. We're going to continue it on Wednesday when we see you.